So now we have 3 fans that can either be off, on low, or on high. And you're just trying to create the right kind of wind. I don't know why you'd set up 3 fans in your room, but maybe you just want the right kind of feeling with the wind. So how would you set all 3 fans? How many different possibilities are there? Well, if we go with the decisions route, we can count this very quickly. We have 3 decisions to make. We have to decide how we're going to set fan 1. And sometimes when we show our work, underneath our decisions, we just do a little explanation of what they are. Fan number 1, fan number 2, fan number 3. How many choices would you have for fan number 1? 3. Choices for fan number 2? 3. Off, low, or high. And choices for fan number 3? 3. There's going to be 27 of them in total. Now, another way to show this 27 with a diagram, and if you had to list all 27 of them, if they said, can you write the sample space? You'd be like, oh, 27 things. How do you do that systematically? Well, we can set up something called a tree diagram. The tree diagram, you look at decision 1, and you draw branches like this for your 3 choices. And since one of the choices is off, one is low, and one is high, these seem like good letters to choose. Then, for your second decision, you have 3 choices off of each of these. Once I set my first one, and it can be off, low, high, off, low, high, off, low, high for the second one. Because whatever I set my first one at, I still have 3 choices for my next one. And then I would have 3 choices. Oh my goodness. You see where the 27 comes in? Are you glad we didn't buy a 4th fan? O-L-H, 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 O-L-H. Whew. And so if we had to list them, the first one would be, ready for this? Oh, that was what you're supposed to all do when I wrote it out now. Okay? So you're supposed to react when I write these out. So let's try that again. First one. Oh, right? And we could keep going and list them all, for example. That was a pretty bad reaction, right? Well, the joke was pretty bad too, but I was hoping you're supposed to laugh out loud, but no, didn't happen. No, there's no ha ha ha. It's H's, L's, and O's. Okay. All right, yeah. So we could list them all. The next one would be ooh and oh and olo and all, and so on. And you could keep. Oh, are we getting fights happening in here? Calm down. So the tree diagram shows 27 branches in total, but can you see how the fundamental counting principle helps us count that even quicker? So to summarize the fundamental counting principle, which is at the bottom of the page, the next page, is that when there are, this is the mathematical explanation here, when there are n1 different objects in one set and n2 different objects in the second set, the number of ways of choosing one object from each set is n1, n2. That make a lot of sense? The way that we've described it so far is when there are more than one decision to make, in order to count all of the choices, we draw spaces for however many decisions, and then we put the number of choices for each decision inside and then multiply. So with the trumpet, we had 3 decisions. Each one had 2 choices. For the fans, we had 3 decisions. Each one had 3 choices. Okay? You can now figure out how many different outfits you could wear when you want to come to school. Because you look, how many pairs of pants do I own? How many shirts do I own? How many pairs of socks do I own? And each one is a decision. I could wear my polka dot socks with my green pants and my striped yellow shirt. That could be an outfit. Okay? Now sometimes if you just use that as your lifestyle, you might come in an outfit that really doesn't work. So hopefully you don't always choose that. But you could say, I can now wear something different to school every single day of the year and never wear the same combination again. Questions for example 1, did I write them down already? Are 3, 4, 6, 11, and 12.